Okay. So what we're gonna do is, I'm gonna show you how to work these problems that are on this worksheet. I'm gonna work out an example. So we're going to talk about specific heat. This is something that we already did last semester, but we're gonna apply it to something that also goes through phase changes, not just like liquid water, which we did before. We're gonna talk about what if ice melts or water boils. So let's look at this graph that we've been going over the last couple of days. We can use the equation that we learned last semester. We learned this equation. The specific heat right here is the mass times the specific heat times the change in temperature. And what was the specific heat for water? You guys remember that from last semester? Yeah.
Zero.
It's not zero.
Repeat the question, please.
Wait.
What is the specific heat of water? How much joules does it take to raise the temperature of water?
4.18.
Yes. Yeah. Yeah. So this right here, we already know it's 4.18 joules per degree Celsius
It's kind of hard to see.
gram. Is it kind of hard to see? What if I do a different color? How about if I? How's that?
That's better.
MC delta T. So mass, so what if I have 10 grams of water, and this is 4.18 joules per gram degrees Celsius. 10 grams of water, and I raise it 10 degrees Celsius. What's the heat required for that to happen? You can do that in your head. 10 times 4.18 is what?
Times 10? 480.
Yes, 418 joules. So, but this is only true right here, right? Because that's the only place that the water is what?
It's water.
Warming up?
It's liquid. It's liquid water. Do you think this number would still work for this part right here?
No.
It won't. It's a different specific heat. What about right here?
No.
You're right. It's not going to work. So we're going to work through an example. We're just going to go through the melting phase. Now, what do you notice about the slope right here when it's melting?
Constant.
It's constant. So what's the delta T if it's constant?
The same?
Delta T, remember, delta T is the final temperature minus the initial temperature. If it doesn't change, what's delta T? No? Look,
Michael.
let's do this. Let's go into this. Can you see down here with the video?
Yeah.
Okay, so if delta T is temperature 2 minus temperature 1, if both of these temperatures are the same, what's delta T going to be?
Wait, say it again?
One.
No, if temperature 2 is the same as temperature 1, what's delta T going to be? 0. Good job. So would this equation work for this part of the graph?
No.
No, because it would go to 0, but we can see that it takes heat to melt. We know that it takes heat to melt, right? So we got to use a different equation. We use a simpler equation, which is Q times mass times the heat that it takes, the latent heat it takes to, we call this the heat of fusion, because that's how much heat you get when water freezes. It's the same whether it's melting or freezing, it's the same amount of energy. Does that make sense? So you could use it going either direction. If it's getting colder and freezing, that's the amount of energy is released when it freezes. If it's melting, that's the amount of energy it takes to melt it. Does that make sense? And it's the same in both directions. Okay. Next slide. We're going to do an example. We're going to go start out at 10 with 10 grams of ice at negative 10 degrees Celsius and go through 10 degrees Celsius. Is it going to change phase through that temperature?
No.
It's not?
Wait, say it again?
If I go from minus 10 degrees Celsius to plus 10 degrees Celsius, will it change phase?
Yes.
Will it go from, what will happen, Michael? It'll go from what to what?
Negative to positive.
No,
No?
the material, the ice that we're talking about, will it
It'll start
change?
melting.
Yeah, it'll start melting, right? So we have to break this up into 3 separate parts. Just like this worksheet's got these, you see how it has these lines right here?
Yeah.
That's so that you could do each individual step.
Oh my god.
So let's do it. All right. So first of all, we're gonna break it up from -10 to 0, right? Let's go to this thing. So we're gonna just do this part right here first, right? Because we have to do each of these separately. Does everybody see that? Because this has a different specific heat. All right, so let's go back. All right, so the specific heat, we're going to use the same equation, Q equals MC delta T, but look at the specific heat of ice. I should change this. This is ice. The specific heat of ice is 2.03 times joules divided by grams per degree Celsius. Now, if I set it up and plug everything in, what can I cancel out in this equation? What units can I cancel out? Can you guys see that? What units cancel out? We got grams, joules, and Celsius. What cancels out?
Grams, joules, and Celsius. Celsius.
Celsius cancels out, yeah. Because this is in the denominator, it's kind of hard to see that, so Celsius goes away. What else cancels out? Grams, right. What's left?
Joules.
Joules. All right. Now, what's 10 times 2.03? What does that equal?
20.3.
Correct. And if I multiply it by this 10 from the delta T right here, what's the answer?
Multiply?
Yeah.
To the 20.3?
Yes, by another 10 because we have delta T is 10 as well. Yeah. There you go.
Yes.
So that's how much joules it takes to get the ice to where it's going to start melting. All right, so tuck that in the back of your mind.
Oh, I'm at
So next slide. So now we've calculated this is going to be 203 joules.
Yes.
Now we need to calculate this. I want to use a different color. We're going to calculate this energy it takes for this to happen here. All right? So let me erase this.
I know you're best friend.
All right, so that's 203. Next slide. All right, so do we have to worry about delta T in this one? No, we just used this simple equation. It's Q. What color we got here?
You messed up, Mister. Come on.
No, I didn't. Oh, I've got the eraser going, that's why. Turn the eraser off. There we go. We've got Q equals M times the heat of fusion right here. And the heat of fusion for water is 334 degrees Celsius. Sorry, 334 joules per gram. So if I have 10 grams, how many joules do I end up requiring to melt all the ice? If it's 10 grams, what's 10 times 334?
3,334.
3,340.
Oh,
Close.
that's what I meant. That's what I meant.
So we have this. Was that an easy calculation?
Yeah.
You just
Yeah.
multiply two numbers together. That's
Just
it.
add to 0, you know?
Yes. All right. So let's go on to the next slide, and now we have this. We can.
Language.
This was 3,340 joules, right?
Yeah.
Now, what's the last step we got to do to get it to 10 degrees Celsius?
No, subtract.
No.
Multiply.
What equation we have to use here in this area?
I don't know, mister. You have to figure
Well,
it out.
if it's this slope thing right here, what's going on when you add heat? What's happening to the temperature?
It's rising.
It's rising. So what equation would you use right here if it's rising here as well?
The same one.
Times.
The same one. Very good.
Oh.
And what's the what do we call that equation?
Put- I don't know, you have to remind me.
The Q. How do you say it? Q equals what?
LL.
Q
No,
equals
That's for the. That's for when it's changing temperature. Q equals what? You said
MC
delta T. Yeah.
delta T.
Now we're not going to go the whole way. We're just going to go up to 10 degrees. We're going to go and say this is 10 degrees Celsius right here. We're just going to go up to here. So we'll use this. Our Q equals MC. Now it's liquid water. So what's the C sub P for liquid water, folks? Everybody knows this. What's the specific heat for liquid water?
Zero.
No.
Ten.
No. Specific heat for liquid water.
Are you dumb?
What's the specific heat for liquid water?
I forgot.
Yes.
Oh.
It's 4.18 joules over grams degrees Celsius. What is our change in temperature? What are we going up to once all the ice melts?
10.
10 degrees. So then what's our delta T equal? What does the delta T equal?
Delta T equals the change in temperature.
Yeah, what is that though?
10.
Yes. So our mass is what?
Our mass would be whatever's in grams.
What for example problem here? I'm doing number one, by the way. Hey guys, I'm doing number one on the paper. This is a freebie.
All right, all right.
So what's the mass for number one?
Mass for number one. 34?
No,
No,
the mass.
I don't know what I'm saying.
We it's the same problem we're working on that we've been working on from the beginning. What was the mass? Somebody else help me out if you can't get it. Number one on the paper. Not the example on the front page, it's the, open it up the next page. There's an example.
10.
Yes, 10 grams. Times 4.18 joules over grams times degrees Celsius times, and what was our change in temperature again?
10.
10 degrees Celsius.
Yeah.
Now what can I cancel out? Can you still see this okay? What are the units that I could cancel out? What's that? Yes. There goes grams, there goes Celsius, and this is pretty easy because we've already calculated this. We already did this as a little quick example. So what's our energy here that it takes to get it up to 10 degrees Celsius? What's this? What goes in here? We just calculated.
418.
Yeah, 418 joules. So all we have to do is add those together.
Yes, we do, mister.
So that's a little calculation, 418. And so to get the total heat, it's 203 plus 418 plus 3,340. That's just adding up all these three things together here.
What would that equal there, mister?
Let's do it.
Let's do it.
Let's get the calculator. Let's go.
Up.
All right, so it's 203 plus 3,340 plus 418 equals, the answer is, let's go to red. The answer for all of it is 3,961 joules. And that's it. That's an example. Now what happens if you got to go all the way to boiling? Then you got to like include all this temperature. This would be 100, delta would be 100 degrees if it was water before it gets to boiling. And then this would be the heat of vaporization. It's just multiplying the mass times the heat of vaporization. And then this finally is back to what? What equation do you use right here, folks?
Same
What
one.
it, say it though. Q equals what?
Q equals.
M.
Yes, C delta T.
Yo.
That's it. All right, you can stop the video.